We're going to try to do calculus today. We've been ranting. Rant is over. Find page 450. Page 450.
What lesson are we on?
This is lesson 5.5. We're going to try to wrap it up today. I'm going to have to push, though, so y'all get it ready to go. Page 450. So I'm kind of in the middle of page 450, and we see this topic called the net change theorem. Net change, okay? On the last problem that we worked, if you push backwards one page, we found the integral in example 4. Okay, so not the last one, but the one right before that. And we had some kind of function that did like this. And we found that the area above the x-axis was positive, the area below the x-axis was negative, and the resulting area above the x-axis was positive. In this way, this is called the net change theorem. It's the net change. So it takes into account the positive area and the negative area, and it subtracts what needs to be subtracted. And your final result is the net. Does that make sense? Okay. If I want to talk about a net profit, I'm going to take into consideration the cost. Okay. I usually get a paycheck. I always get a paycheck. I get a paycheck once a month. And they have calculated my gross income, which is income before taxes and insurance and blah, 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 blah. And at the end, they have my net income, okay? And that's going to be my gross minus all of those deductions that are taken out. And so the net income is what I actually take home, okay? That's the same way that this works. This is finding the net area, the overall. Now, if overall turns out to be negative, then that means you had more area under the x-axis than you had above. If your net turns out to be positive, you got more on top than below. Are we understanding how this is working? This shouldn't be new to you, but it applies differently to different situations. They have examples of net change theorem in action at the bottom of page 450. Do y'all see where those are? It says, let V prime represent the rate at which water flows into a reservoir. Then V of t is going to be how much water is in the reservoir at time t. And that's equal to the net change in the water. Okay, how much water is flowing in. You could do concentration of a chemical reaction. They have mass. They have rate of growth of a population. What's happening in a population that some of it might be negative? Right? Okay, so we've got some kind of mortality rate, and we've also got some kind of birth rate happening in a population. You're gaining some and you're losing some. And so the net change is going to be the difference. Okay? But where this really gets applied to what we do in our physics class is number 6. Can y'all find number 6? This is at the bottom of page 451. Number 6.
Yeah.
Cohen, would you read that for us? I'm like dying up here. I need you to read it.
Okay. If a particle moves along a horizontal line so that its position at time t is given by s of t, then its velocity is v of t equals s prime of t. And the integral from t1 to t2 of v of t dt equals s t2 minus s t1.
Perfect. This is like I gave you all of the lineage of Zeus or somebody. It's something awful. You have now read like Malachi to Methuselah to... Good job. Excellent. Keep going.
Okay. That is the net change position or displacement of the particle over the time period from t1 to t2. We have already seen examples in which this was true for a particle moving only in a positive direction. However, now we can interpret equation 10 as the net change in position of the particle over the time interval t1 to t2.
Okay, cool. So when we're calculating with net change, we're finding displacement. Remember that displacement doesn't tell direction. Displacement tells distance traveled, but only from 0, from our starting point. So if this little inchworm crawled 2 meters to the north and then turned around and came back 1 meter south, his net displacement or net change is only 1 meter north. Do y'all understand what that's saying? Okay, so when we find the net change, we're finding displacement. Net change in velocity is displacement. So keep going with number 7. Who else would read number 7?
Oh, so too. I'm enjoying.
Cohen, we're enjoying your therapeutic reading. Continue. Number 7. He said, I don't like
Total
this.
distance traveled by an object over a time interval, then theoretically, we have to consider separately the intervals where v of t is greater than or equal to 0. The particle is moving to the right, and the intervals where v of t is less than or equal to 0. The particle is moving to the left. However, we can simplify this process if we consider the function the absolute value of v of t, the speed of the object. Therefore, the integral from t1 to t2 of the absolute value of v of t dt equals total distance traveled from time t1 to time t2.
Yeah, perfect. So the idea here is if you want distance, you're going to have to rig it. Because the integral of velocity is the net change. That tells me displacement. If I want distance, I need the absolute value, the integral of the absolute value of velocity, so that I can accumulate whether it's going north or south, whether it's above or below the curve. I want the total. I want the absolute value. So ask your question.
On a graph, like when it's going to go below, would it look like it just like bounces to this, say, like?
Correct. So if I was going to rig this picture that I've drawn up here for you, it's going to look like it goes here, and then it's going to have to invert that negative, right? We're going to have to flip it up. He said, does it look like it bounces? Kind of. We're going to have to make the negative part happen above. Okay, that's kind of in our mind what we're doing. What we're actually going to do mathematically, when we want the absolute value, is we're going to find the interval on which it's positive, and we're going to break it. And then we're going to add the negative part. We're going to break it again, and then we're going to add the last part. And that way we undo the negating that happens when we just integrate normally. Okay? Are y'all with me on this? Kind of understand? Okay, so turn the page to page 452. At the top, you can see that displacement would have area 1 minus area 2 plus area 3. So let this be area 1 minus area 2 plus area 3. This is a perfect picture of that. That's a 3. That would be displacement, okay? But for total distance traveled, we want to add up area 1 and area 2 and area 3, okay? And so how we do that is we take the absolute value of that velocity curve. We're going to do example 6. Okay, so join me on example 6. This is straight from page 452. It says a particle moves along a horizontal line so that its velocity t equals 0, is given by v of t equals t squared minus t minus 6. So our function here, this is for example 6, our function v of t equals t squared minus t minus 6, where v is measured in meters per second. Find the displacement of the particle during the time interval from 1 to 4. So part A says find the displacement. I'm going to switch my colors here. Find the displacement. And if you'll remember, displacement is net change. I want to take my positives, I want to subtract the negatives, and I want to deal with what's left. Okay? So we're dealing with net change of this particle on the interval from 1 to 4. Not -1. That's goofy. Why did that happen? I don't know. Okay, so all we have to do in this case is integrate. Okay, this is going to be the integral on 1 to 4 of v of t. And that's going to help us find... That's going to help us find the displacement at 4 minus the displacement at 1, and we'll know the difference. Everybody kind of seeing what we're doing here? So let's plug in that velocity function. We got t squared minus t minus 6 What's the integral of that, or the antiderivative of that?
T cubed over 3.
Minus,
T squared over 2.
minus,
16.
and we're going to evaluate that on the interval from 1 to 4. So we're going to have 4 cubed over 3 minus 4 squared over 2 minus 6 by 4, and then what?
Minus that vote.
Parentheses. That's what I was looking for. Good job. 1 cubed over 3 minus 1 squared over 2 minus 6 by 1. Okay. I'm going to write on the side of my paper over here. 4 cubed, that's going to be 64 over 3 minus 16 over 2 minus 24 minus 1/3 plus 1/2 plus 6. Did y'all get the minus and the pluses?
I think, maybe.
Why? Because I put parentheses, and I understand that that changes all of these 3 sides.
Yeah, maybe.
64 divided by 3. I'm going to leave that as 64 thirds. That's not nice, is it?
No.
This one becomes 8. So that's kind of helpful. If I group up my whole numbers, 8 minus 24.
Negative 16.
No, negative 8 minus 24.
Negative
Keep going.
Oh, yeah.
Negative 32 plus 6 brings me out of the hole to negative 26. (64 thirds minus 1/3). 63 thirds.
Oh, that
Is that divisible by 3?
is.
63 thirds? Huh? So negative 26 plus 21 puts me at negative 5. And negative 5 plus 1/2
Type something in.
puts me at negative 4.5 or negative 9/2.
Never mind, I typed it in right.
Okay, so this tells me that my displacement came out at negative 9/2 or negative 4.5 meters. Let it be meters. Yeah, it is measured in meters. Negative 4.5 meters. So what does that tell me?
There was more under the graph than there was over.
There was more under the graph than above. Okay. So in relation to the particle, let it be a ladybug, where did the ladybug end up?
Backwards.
Backwards. She went 4.5 meters to the left. We can tell that because it ended up negative, right? So from the center, from the origin, from the starting place, she ended up displaced 4.5 meters to the left from home. Yeah? Okay? But that doesn't tell me how far she went. She's on a horizontal line. She might have been confused. She might have been yelling about a house fire and going back and forth. Ah, have y'all not heard that little riddle of the ladybug getting all of her kids out of the house with the fire? No. Yeah. Somebody has heard of that. Not you people. It's fine. Okay, so part B, find the total distance traveled in this same time period. Find the total distance traveled in the same time period. So we still have V of t is t squared minus t minus 6. Okay, that's still our function. But this time we're looking at total distance traveled. Well, if I'm still on the same interval, I'm still on the interval from 1 to 4, now I need to consider what? Maybe I want to say now I need to consider when. When what?
When everything's positive. I don't know.
It switches from.
When it switches. On the interval from 1 to 4, when does this function switch? Okay, so I want you to imagine this function, right? What kind is it? It's a parabola. Okay, and we want to know, right? And we're on the interval from 1 to 4. I'm going to guess that this parabola looks something like this. Right? We're starting at t equals 1. So really, we're interested in this business from here on to 4. But what we need to know is where does it switch from being negative to being positive so that then we can find the absolute value. Okay, so how do we do that? How do I find when a parabola crosses the x-axis? Set it equal to 0. Factor it. Cool, let's do it. Lauren did algebra 2. Factors of -6 that make -1. -3 and 2. Good. And so we know that this occurs when t equals 3 and when t equals -2. Look, that's probably this guy right here. Throw him out. He doesn't get to play. He's too negative. That was funny. Okay, so we know that the time happens at 3 that this hits the x-axis, that this occurs. So what we want to do is we want to have the area, we want to integrate on the interval from, so really this should be the absolute value of v of t, right? That's what we're doing. We're saying I want the absolute value of v of t on 1 to 4. That's going to equal taking from 1 to 3 the negative integral of v of t dt, because we know that at 3, everything from 1 to 3 is below the x-axis. So we can negate that, and this is kind of what Cohen was saying, by flipping it upside down. We want that piece of information up here. So we make that negative. Plus everything after 3 to 4. And that we're going to integrate straight because it's all above the x-axis. Are y'all following this? Nikki, can you push the air conditioner button back there? Down, 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 down. It is easier on the calculator.
If it started on the, like, if we did have the -2 part of it, would there be multiple
Okay, so we're going to have the integral from 1 to 3 of negative v of t. I think it's easier if you just switch your signs on your function before we start this integration process. Plus the integral from 3 to 4 of v of t. Any questions on what we're actually doing here? Do it by hand, and then I'll show you the calculator. I'm sorry. Do it by hand first. I'm not having a whole lot of sympathies. I'm having one sympathy.
It really quickly stacks up to a lot of like hand work.
It really does.
That's why it's a bunch of them. Yeah. That's why I did it. Calculated. No.
Anybody get an answer yet? Is it a lot? You want me to let you do it on the calculator?
Well.
Okay, so options on the calculator. Options on the calculator. Let's look at it, okay? You may go on the interval from 1 to 3 of negative t squared plus t plus 6 dt plus the integral from 3 to 4 of, what is it, t squared minus t minus 6t, minus 6 dt. Type this in your calculator and have it integrate. First one to win wins.
10.17.
You get all the points.
I get all the points. 10.17.
Seth, you can't have the points.
Why?
Somebody else get the points.
Why can't I have the points? Because I typed it in first.
10.167. Make sure we're rounding to 3 decimal place. 10.167.
My bad.
3 decimal places here, guys. Make sure, always, 3 decimal places. Okay, so here's one thought. You could chunk it. You could figure out where do I need to break it, and I'm going to integrate the first piece plus the second piece, right? I'm going to negate the negative piece by doing the negative function. Any questions on that? Everybody's good with it.
I had a question.
Okay, what?
Alternative method.
No, I'm going to tell that. Don't steal my thunder. Alternatively, I could just make the whole function be positive by taking the absolute value. See, I told you, don't steal my thunder. By taking the absolute value of the function. So try this. On your calculator, the integral from 1 to 4 of the absolute value. Now that's ABS, open parentheses, insert function, close parentheses. ABS, open parentheses. That's how you do absolute. You could also do the next door to the Book of Wonders.
That's what I do.
And you could push that button and you see these brackets, vertical brackets.
Like you literally just type A.
You could do ABS, open parentheses.
That has the other thing too.
Oh.
What was the other option?
Next door to the Book of Wonders.
What
If
is
you
the-
type the little button.
What?
Next door to the Book of Wonders. This is the Book of Wonders.
Okay.
Next door to that.
Did we ever use the
There's
Book of Wonders?
a button that has absolute value. That one right there.
What?
Yeah, did we use the Book of Wonders?
I need to try that.
What'd we get?
Same.
Same thing. 61/6 or 10.167 to be precise. Now, talk to me about what this is in context of this problem. Remember, they're particles of ladybug.
All the distance.
How much distance it traveled overall?
All the distance that she traveled in total. Okay, so it feels like she was going back and forth, back and forth, back and forth. And where did she land? Finally, 4.5 meters to the left of where she began. Do you understand the difference? Okay, net change, displacement. Total distance, though, you're going to have to absolute value that. Okay, let's move on to example 7. Example 7. In your textbook, it says a particle moves along a horizontal line so that its acceleration at time t greater than 0 is given by a of t equals t. Okay, so example 7. A of t equals t times the square root of t to the 4th plus t, where t is measured in seconds and its position is s in feet. If its velocity at time t equals 2 is 5 feet per second. Velocity at time t equals 2, so v of 2 is 5 feet per second. What is its velocity at time t equals 4 seconds?
What is T?
Take the integral on what interval?
2 to 4.
2 to 4. Okay, so we're going to be able to find its velocity at time t equals 4 seconds by analyzing the acceleration or the integral of acceleration from 2 to 4.
And we add it to 5.
Okay, so he said, do we add it to 5? Well, let's write this out. This is the fundamental theorem of calculus. It's that big deal. Okay. The integral of acceleration on the interval from 2 to 4 is velocity at what? Velocity at 4, f of b, minus velocity at 2, right? And we are looking for a velocity at time t equals 4.
Can we do 0 instead of 2 to make it the whole thing? Because I thought we wanted that.
No, we want to know its velocity at 4. And we already know its velocity at 2 is 5. So we could do, what if we add that 5 to both sides, right? Add v of 2. So really we could say v of 2 plus the integral from 2 to 4 of a of t dt tells me v of 4. Can you see that? Just a little algebra. Swing that back into the other side.
Wouldn't that also just be like the integral from 0 to 4? Because
Starting at 2 and then going to 4. If you already know its velocity at 4, at 2 is 5, plus, I'm going to let you use your calculator here, mainly because we don't have any rules for integrating by hand a product of this and square rooty business and other stuff. Stay tuned. We'll learn that later this week. Womp womp. But for today, type on your calculator the stuff. So v of 4 is going to equal 5 plus the integral from 2 to 4. Blah, 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 blah.
can I get all the points again?
No, you have to save them. To put them in a baggie in your pocket, like your phone. Lily's going to get all the points.
All the points?
I'm going to let you have them. You're earning them right now. We're just going to assure that you win.
She doesn't want to listen to it.
Okay, I got 65.9886.
Perfect. So rounded to 3 decimals, 65 point. Oh, now it's really hard. 989.
What? That's not what I actually got.
See, I told you did not get all the points.
Wait, no, how did I not get it though?
Negative calculator points are set.
No,
You have lost your points and then some.
no. What?
Net change is negative.
What?
Ask Lily. You're going to have to ask Lily for help. Lily got it right. Ask Lily.
Oh my gosh.
This is fantastic. Okay,
I'm not telling you.
look with me. I don't want to know. Look with me at page 453. Last thing, really quickly. Page 453. You've got this power consumption graph. Y'all see that there's no function here? Ugh. So your idea here is, how would you tell the total power?
I guesstimate.
Guesstimate. What other tool do you have if you don't know the function? What could you do? Okay, you don't know the function. Area of each little bitty increment. That's called a Riemann sum. That's what they want you to get at here. If you don't have the function, you're going to have to resort to some other nasty method. Okay, that's the end. Everybody hear me. Freeze. Freeze. You can't order lunch anyway, so just freeze. Just everybody sit still. You have that is the end of lesson 5.5. Okay, so you should have started this lesson homework on Friday. In theory, you have the entirety of this lesson's homework to do. Okay, we start 5.6 tomorrow. Everybody okay? Okay, Seth, ask a friend.
Well,